So good morning all. In this class we'll discuss how to find out addendum for pinion and gear. So just look at the statement. The number of teeth on each of the two equal spur gears in mesh are 40. The teeth have 20-degree inward profile and the module is 6 mm. If the arc of contact is 1.75 times circular pitch, you have to find the addendum. So the number of teeth are same for pinion and gear. So you can take T value, that is 40. Okay, so this T is 40 for pinion and gear. Okay, then pressure angle is given pi. So this pressure angle value is 20 degree. Okay, module is given 6 mm. Okay, and the correlation is given length of path arc of contact is 1.71 times circular pitch. Okay, so basically what is circular pitch? Circular pitch is nothing but pi into m. So we have module value of 6. We can write pi into 6, 18.85 mm. Okay, and length of arc of contact is 1.75 times circular pitch. So we can put this value of 1.75 into 18.85. So you'll get 33 mm. That is the arc of contact. So we have correlation between path of contact and arc of contact. So basically length of arc of contact is path of contact upon cos phi. So we can calculate this length of path of contact by just considering arc of contact into cos phi. So value of arc of contact is available, that is 33 multiplied by cos 20. Pressure angle is given 20 degree. So 33 into cos 20, we will get value of path of contact, that is 31 mm. So once we have this value of path of contact, then we can find out circular pitch and addendum value. So what we have, this R value, this addendum will be MT upon 2, module into number of teeth upon 2, that will be 120 mm, this circular radius. Okay, so as we have same number of teeth on pinion and gear, so this circular radius will be same for pinion and gear. So can we take that arc of contact value 31 is equal to path of contact value 31 mm is equal to this RA square minus R square cos square phi plus under root of R square minus R square cos square phi minus this piece circle is R plus R into sin phi. So we have this 2 into under root of R square minus R square cos square phi minus R sin phi. So we have RA value addendum radius 126.12. Okay. So addendum of the wheel will be this addendum radius minus piece circle radius. So 126.12 minus 120. So you get addendum value for this wheel is 6.12. Okay. Now look at the next part. So we have a pair of gears having different number of teeth, 40 and 20, and this they are engaged, and the speed of smaller pin gear is given, that is 2000 rpm. We have to determine the velocity of sliding between the gear teeth face at point of engagement, at each point, at point of disengagement if the smaller gear is driver. And we have to assume that gear teeth are 20 degree inverted form. Addendum is given 5 mm. Module is also given 5 mm. And to find out angle through which the pinion will turns and the pairs of teeth are in contact. Okay. So just look at the given data. So we have this number of teeth on gear 20, number of teeth on pinion 20. Then N1 is speed for pinion is given, that is 2000 rpm. Pressure angle is 20 degree. Addendum value is available, that is addendum for this part is 5 mm. Okay. Then we have the value of module. Okay. So what is the module value? Module is same 5 mm. So first we'll find out angular velocity for smaller gear, omega 2 pi n upon 60, 2 pi n1 upon 60. So that value is 209.5 radian per second. Then we can calculate angular velocity for larger gear. So you can just equate the correlation. Omega 2 upon omega 1 is small t upon capital T. Small t number of teeth on pinion, that are 20. Okay. Capital T number of teeth on gear, that value is 40. So 20 upon 40 equal to this omega 2 upon omega 1. So it is omega 1. Omega 1 value is available, that is 209.5. So if we put that 209.5, so we'll get value of omega 2. So that omega 2 value is 104.75 radian per second. Okay. Now piece circle radius is mt upon 2. Okay, that is module into number of teeth upon 2. So module is 5. When number of teeth on pinions are 20. So 5 into 20 upon 2. So number of piece circle radius for pinion will be 50 mm. Similarly, piece circle radius for gear, capital R is mt upon 2. It is 5 into 40 upon 2. So this piece circle radius for gear will be 100. So we have this piece circle radius for pinion and gear. Then we can calculate addendum radius. Addendum radius is piece circle radius plus addendum for pinion, piece circle radius for gear for pinion. So addendum is same. Okay. So this addendum value is same. That is 5 mm for both the case pinion and gear. So you can put that value 50 plus 5. This value is 55 mm and 100 plus 5, 105 mm. So you can get the value of RA, small RA, addendum radius for gear, capital RA, addendum radius for larger gear. Okay. Now next, we need to find out path of approach and path of process. Now to calculate path of approach KP, we have value of addendum radius for gear and piece circle radius for gear. Okay, that is larger gear. So we have RA value. RA is 105. So the equation is KP is equal to under root of RA square minus R square cos square phi minus R sin phi. Okay, so just put the value of that KP under root of 105 square minus 100 square cos square 20 minus 100 sin 20. So we'll get that KP value 12.65. Similarly, path of process is R square minus R square cos square phi minus R sin phi. 55 square minus 50 cos 20, 50 square cos square 20 minus 50 sin 20. So this PA value will be 11.5 mm. So in this way, we can calculate path of approach and path of process. Okay. Then next, we have to find out total length of path of contact. So that total length of path of contact we have, that is addition of both these approach and traces. So next we have to this addition we can calculate. The next velocity of sliding at the engagement. It is asked to calculate velocity of sliding at engagement and disengagement. So we have omega 1 value and omega 2 value. So it is omega 1 209.5, omega 2 is 104.75. Just add both this part and multiply by path of approach distance to get velocity at engagement, that is at beginning. So basically velocity is R into omega. Okay, so just we have these both the pairs, that's why we are writing omega 1 plus omega 2, and this R distance is nothing but path of approach distance. So this part is 209.5 plus 104.75 into 12.65. We'll get velocity at the start 3975 mm per second. Okay, similarly velocity is at pitch point. So there is no any velocity, sliding velocity at pitch point, because gears are perfectly engaged at pitch point. So sliding velocity of sliding at pitch point is always 0. Okay. Then one more point we need to find out velocity at the disengagement. So velocity of gears at disengagement is again to get the calculation of velocity at disengagement, we have to consider distance of path of process. So omega 1 plus omega 2, 209.5 plus 104.75. Just multiply by distance 11.5, distance of disengagement. Okay, the distance we have discussed. So that part is 3614 mm per second. Velocity at disengagement. And we need to also find angle through which this pinion turns. So arc of contact already calculated. Okay, it is 25.7. Okay, so multiply by 360 degree upon circumference of pinion. Okay, so based on this, we'll get the angle turn by pinion, that is 29.45 degree. So we can calculate angle turn by pinion and angle turn by gear also. Just we have to take the circumference for pinion. So circumference for pinion is 2 pi r. Okay, just we are putting the value of r, that is piece circle radius for pinion. Okay, so if we take this, just 1 minute. If you take this r value 2 pi r into r, then we will get angle turn by pinion. If you take 2 pi r, capital R, then we will get value of angle turn by gear. Okay, so in this way, we can find out angle turn by pinion for given details. So this value is 29.45 degree. Okay, so this is all about the calculations of uh, velocity at engagement, at pitch point, at disengagement, how to find that angle turn by pinion and gear, how to determine the path of approach and path of process for simple gear pair. Okay, so stop here.